So, linear systems. Before we carry on, we need to do some obvious discussion about some terminology. So, first, a system of equations. You people are smart young people. What do you notice about that word right there? It is plural, which means a system of equations must have at least how many equations? 2. Brilliant. Good job. What is a system? In English, not math. What is a system? Jordy, how would you define system?
Well, I would define a system as a machine that functions through work.
Okay. So, if the machine... one second. You're going to refine that right now?
I was going to say it's a sequence that helps keep everything organized.
Okay. So, we have 2 different definitions. I would argue that they are not that different because I think the spirit of Jordy's definition is the work that gets done transforms something to something else. And to do that, it must pass through various processes. That is how I heard what Jordy said. And I agree completely. So, a system of equations is indeed that. A system of equations is a group of at least how many? 2 equations which may, and please underline or highlight may, which may have a solution. Not a solution, a solution. Why have I said may? You're about to find out. Now, let's write a couple of things down here. X plus 7. What is the solution to that? Jordy?
Well, you need to put equal.
Absolutely. There is no solution to that because that is not an equation, right? That is an expression. I will refine it slightly. X plus 7 equals 10. What is the solution to that? Why?
Because it's equal sign. And with the equal sign, you can move the 7 onto the other side. Then you flip the equation, it'd be minus 7. Then
So you do algebra and you find the answer. Excellent. What is the solution to that? That did sound doggy, didn't it? I heard that too. But it sounded like it was on the roof. Dogs do not climb roofs. What? Squeaky desk? Yeah. Oh, I don't. Yeah, I could hear that. One should not discount all dogs from the ability to climb roofs. If you ever find yourself in the Hoover Dam in Arizona and you take the dam tour, it's a damn good time. No, it really is. The dam tour is cool. Anyways, if you go and you take the dam tour, you will find that while they were building that, the builders adopted a stray dog. And that dog could indeed climb the ladders and stuff. And it walked all over the Hoover Dam until it fell into some wet concrete. Or something like that. Oh yes, the dog is dead. But it is buried. It is buried at the Hoover Dam. Like its grave is right there. It's kind of neat. Something like that. I don't remember the exact story. I haven't been at the Hoover Dam in like 3 years. Anyways, I've been to the Hoover Dam thrice. It is a huge dam just outside of Las Vegas. It is an engineering marvel. An environmental catastrophe, but an engineering marvel. Now, where was I? The green one. What is the solution? There isn't a single solution. Why?
Because the variables can have multiple values.
Excellent. There are two variables. And when there are two variables, one cannot ascertain a single solution because there are two unknowns. Huh? Excellent. So, now that that's been established, let us move on to the next line. A linear equation. What is a linear equation? We've just done 2 whole units on them. Jordy? That's part of it. But there need not be a slope to have a linear equation. You can have a slope of 0 and it's still linear.
When graphed, it's a line.
Oh, okay. A linear equation is
An equation.
that should be an equation which graphs as what? As a straight line with what? What is special about it? Yes, a constant rate of change. Right? Yeah? Excellent. And if we were to put that linear equation on a graph, that linear equation would be made up of what? Talk to your neighbors. Figure out the question I just asked. There is a line on a graph. What is that line made up of? Points. And those points are all? Excellently done. Now, is every line made up of X's and Y's?
Yes.
No. Maybe.
I'll refine the question. Is every line made up of independent and dependent variables?
Yes.
There we go. And we define those independent and dependent variables with X's and Y's, yes? All right. So that tells us that if I have a line, y equals mx plus b, what do I know about the x and y's that exist on that line? What do I know about those x's and y's if I have an equation? What can I do with them? Mathematically speaking. I've already got a slope. It's m. I can substitute them back into that equation, yes? And what will happen? The equation will be what? We'll go back to this example right here. Okay? 312. Is that point on that line? Why not, Zimmer? You shook your head no, and I told you you're right.
I'll let him finish.
I am concerned as to why Shitu is not answering this question, because he was the one that said you could sub them back in. So we are now working with that and that. Is that point on that line? Amazing. I didn't even see Shitu's lips move. No, of course not. Why? Because 3 and 12 don't add up to 10. So, I'll ask again. The x and y that exist on that line right here, what can we do with those x and y's if they exist on that line?
Well, I mean,
I know you would, but regardless of what the slope and the y-intercept is, what can I do with them? Shidu has already said I could put x in there and y in there, yes? Then what would happen mathematically if I put y there, a pink y, and a pink x there? What would happen if this was a linear equation? Raj. They would be equal. Whereas up here, they were not equal. So this point couldn't exist on that line. Is everybody okay? All right. Now, you're smart young people. If a system of equations is a group of at least two equations that may have a solution, and a linear equation is one of these, anything that graphs in a straight line, what then must a linear system be?
Multiple equations that can be graphed on both lines.
So close. I like where you're going. A linear system is a group of how many? At least two what?
Equations.
What kind of equations?
Linear equations.
At least two linear equations. Keep going.
That can be.
I would use which.
Oh, which has a constant rate of change, or would it be the graph? Which can be graphed as a line on a graph. Which has a constant rate of change.
But how can two different lines have a constant rate of change?
Which are parallel?
That would make them parallel.
I don't know what I would say here if the graph isn't right.
Thank you. Thank you. Read the two definitions we've already written.
A group of at least two equations which may have a solution. That is a system of equations. A linear equation is an equation which you graph as a straight line with a constant rate of change.
So a linear system, if it's got to be a group of two equations, then how many lines will I have?
2 lines.
At least 2 lines that may have a solution. Group of at least 2 linear equations which may, and I should highlight that, may share a solution. Now, if all lines are made up of x's and y's, then I must be seeking, if I solve a linear system, what must I be trying to find? And what is that solution going to be? No. A line has an infinite amount of solutions. Like this line right here could be 9 and 1, 8 and 2, 3 and 7. Infinite solutions. So what solves a linear system? We've already got the equation. We've already decided that it makes 2 lines. We've already decided that lines are made up of x's and y's. And if the x and y works in the equation, works on the line, it works in the equation. So what must I be seeking if I wish to solve a linear system? You can put this together, ladies and gentlemen. What is a linear system? What is it going to look like if you graph it? Read the definition of a linear system. There's a graph. What would it look like? There'd be 2 lines. Excellent. There is one line. There is the other line. What is this pink line made up of? X's and Y's. How many? Infinite. So there are infinite solutions to the pink line, yes? What is the blue line made up of? X's and Y's. So there are infinite solutions to the blue line, yes? Is there an X and a Y that is a solution to both lines? Where? Where? Anywhere?
Anywhere on the line.
No. This XY is not a solution to the pink line.
Oh, no.
This xy is not a solution of the blue line. Where is the solution? Where they intersect. So I will ask again. To solve a linear equation means to find the point, which is, but what is the point made of? Excellent. To find value for x and y that do what? Yes, that solve both. What if there? Oh, there you go. That solve all the equations in the system. Whew. Three ways to do it. Graphing, elimination, and substitution. Today we are going to discuss graphing and graphing only, because we've just been doing it forever. You now know this answer. Solve by graphing, you find where the lines cross. Because where the lines cross is an x and y that are on both lines, right? So, step one, graph them. The easiest way to graph is this. Now, will you always be able to get a nice, easy slope-intercept?
No.
No, not always. But the principle, the concept that goes with this is most easily illustrated if we always use slope-intercept. So, what is M? Slope. How do we find slope? Lots of different ways.
First, we can either count because already graphed.
Count.
Or we can use m equals y squared, or y subscript 2 minus y1.
y2 minus y1 over x2 minus x1.
Yeah.
Right?
Yep.
Or
Y minus y1.
it's just the M from the equation. Right? And what's the B?
The y-intercept.
The y-intercept. Now, what do we have to remember about the y-intercept? It might be written as,
Fraction.
could be, 0 comma y. But whatever it is, it's the y-intercept, even if it's a fraction, yes? So step one, we convert. Step two, we graph. Step three, we find the pair. Easy peasy lemon squeezy, yes? So let us do so. Here is a graph. How many equations do you see? 2. Does that make this a system? Yes, it does. So, first thing I will do is graph the first one. X plus y equals 4. What would be my first step? And really the only step I need to do here. Isolate y. Y equals negative x plus 4, yes? Where do I put my first dot?
Plus 4.
1, 2, 3, 4. What's the slope?
Negative 1.
Negative 1. So however far down I go the same distance where?
Left. No. I don't know. I don't know.
Graph a line, dude. However far down I go, if I need a slope of negative 1, how far to the right or left do I go?
1.
So if I go down 20, I'm only going over 1? No. I'll ask again. If I go down any amount, then where do I go? That same amount in which direction?
If you go down, you go right.
There you go. So there is the first line, yes? Now, for our purposes, I'm actually going to use dots, because I have a shaky hand, as you are all well aware. Now the blue line. Negative x plus 2y equals 2. 2y equals x plus 2. Y equals what?
Equals x plus 1.
1/2 x plus 1. So where do I go? And then?
Then you go up 1, right 2.
Hey, and what do you see right there?
Intersect.
An intersection. At what point?
The right 2 up 2.
So what point is that?
2 and
2,
2.
2. And I'll use purple because they, red and blue make purple. Now, does it work? Is 2 plus 2 4? Is negative 2 plus 4 positive 2?
Yeah.
So did I do it right?
Yeah.
Yep. Now you all get to do it for number 2. Go.
Go.
Let's go. Lego my egos. And when you have an answer for me, cluck like a chicken. Really? Okay, you don't want to cluck like chickens. Mule like a platypus. See, nobody even knows the sound a platypus makes. Mewling as in MEWLING, not as in you're carrying drugs across other country, over the border. You're not a mule. All right, what was the answer? What was the answer? Raj? 2, negative 3. Spectacular. Now, ladies and gentlemen, the next thing here, how many of you have seen that notation before?
Absolute value.
Never.
So the answer there that I was seeking, Jordy, was yes. How many of you have seen that? Absolute value. Would you like some pizza? Absolute value. Would you like some Coca-Cola? Absolute value. Would you like a punch in the mouth? In absolute value? Let's try this again. Obviously, Jordy has seen it. Yes, it is absolute value. And do you all know what it means? Absolute value is simply a distance. It's a scalar, right? It's got a magnitude. It is the distance the number is from 0, okay? Now, this is not going to be on a test. I'm doing this. You'll see why I'm doing this in a minute, okay? But I have to make sure everyone's on the same page because it proves a concept for here. There's 0, yes? If I were to put a point on the number line that is 2 steps away from 0, where could I put it? I could put it at positive 2 or negative 2. Because this distance is 2. Direction doesn't matter. Everybody with me? So what then is the absolute value of negative 7? 7. What is the absolute value of 7? 7. Everybody good? That's all you need to know for this. You'll be doing a lot with absolute value in grade 12, but right now I'm doing something else with it. So if I wanted to graph this, because most of you haven't seen that notation before, and you're not sure what to do, most of you, I would like to think, would go straight to a table of values here, yes? So when x is 0, what's y? Because you're 0 steps away from 0, agreed? So I'd put a dot at 0, 0. When you are 1 step away from 0, how far is that? 1. When you are negative 1 away, how far is that? 1. When you are 2 away, how far is that? When you are negative 2 away, how far is that? And you would make this graph. Agreed? Because we could never have a negative, because negative implies a direction. Everybody cool? All right, so there's our graph. Now, how would I graph this guy? How would I graph the second equation there? He waited patiently. You would start at 3 and then do what? You would start at 3, 1, 2, 3, and right 2 up 1. Okay, you're doing run over rise. That's cool. And what do you notice right there and right there? 2 intersections, which means how many solutions is there to this system? 2. What are they? What are they? My shaky hands have gotten me in trouble again. There and there. Negative 2, 2, and 6, 6. And we check. Is the absolute value of 6, 6?
Yes.
Is half of 6 plus 3, 6?
Yes.
Is half of negative 2 plus 3 positive 2? Yes. Is the absolute value of negative 2 positive 2? So as you can see, as long as the lines cross, there is a solution. Agreed? Now, what I mean by that is, what if I had something like this? How many solutions does that system have? 2. Good. How many solutions does that system have? 2. Excellent. How many solutions does that system have? 1. They're supposed to be touching. I'm shaky. Leave me alone, Connor. How many... How many systems or solutions does that system have? 4. Does everybody understand? As long as the lines cross, they have a solution. Now I'm really going to mess with your heads. How many solutions does that system have? None. Tell me why. That's your first step of homework. Your next step is page 188. See you tomorrow.